Hello team. Today we're going to talk about network attached storage and storage area networks. So network attached storage, or NAS, is one of the ways in which we can get remote storage. And there are many ways in which we can get a NAS these days. So one of them is called host-based NAS. Most operating systems today have built-in support for sharing a file system over the network and to mount these file systems locally. So here, for example, I have a screenshot from Windows where we can, go into the properties of a hard drive like d:\\, and we can share it. And when we share it, it's going to have a network path. And then we can mount a network drive from Windows Explorer. And macOS and Linux have similar functionalities. So this is one way in which we can have a sort of NAS on our computers. The turbo version of this is when we have a dedicated server. And there are servers that are custom built to have a lot of disks. So they add disk controllers to the server and they build these multiple unit servers like 4 units or 3 units. And then they have several disks on the same server. So in the end, if you put large disks inside this server, this server is going to have like a gigantic amount of storage. And then you configure networked file systems or some block storage manager on this server so that you can access all of these storage from other servers in your network or from other servers in the data center. And finally, we can have dedicated NAS devices. So these are custom built devices and they usually run a proprietary operating system and a proprietary software stack. So you basically plug them into your network and then you have this NAS. They usually have a web interface that you use to configure the device, and then you can just map the drives over the network and use them on your other devices. So here I have a screenshot of a QNAP device with 4 hard disk bays. So you can add up to 4 hard disks on this device, and it has an Ethernet port to connect it to your home or office network, and then you can basically use all of the storage on your other devices. And of course, there are also dedicated NAS devices that are enterprise grade. So here we have a Synology NAS. And these devices usually use high endurance hard disks and components so that they reduce the mean time between failures to ensure that the disks are operational most of the time. And these devices also have integrated, so you can buy 2 of them and then connect one to the other, and then it's like you have a jumbo NAS with double the capacity. So you can combine them in advanced ways. But it's the same idea of the small NAS device over here. So these Synology devices run a proprietary operating system. If you want to tinker with it, that's very hard to do because they come with their own software stack. Okay, the storage area network is an extension of this idea of using NAS. In a storage area network, we have network attached storage, but we also have a dedicated network infrastructure to access this storage. So if you think of a data center using a storage area network, it's like you have 2 networks. You have one network for north-south traffic, and then you have another network for data traffic, from the storage service to the actual compute service. So this was proposed, but it ends up being very expensive, building a second network just for transferring data from the storage service to the compute service. So it's not very useful to have dedicated storage area networks these days. So what we do instead is build a standard Ethernet network with a lot of capacity, and then we run the protocols to access remote servers on the same Ethernet network. So we run everything on the same network and cut costs on cabling and building 2 networks. And these modern networks that run both data traffic and disk traffic are called hyper-converged infrastructure, because these networks run multiple protocols. And sometimes the storage area networks, they have dedicated protocols for transferring data like fiber channel. So let's contrast network attached storage with storage area networks. So network attached storage usually exports a file interface. So we have this network file system that we mount on other devices in our network. Storage area networks can also export a file interface, but they usually export a block interface. So we create virtual disks on our storage area networks, and then these virtual disks are used by other servers and other virtual machines in our network. One limitation of network attached storage comes from using network file systems. So file systems are OS specific, so each operating system has its own file systems. So the way in which we access a network file system might be limited depending on which operating system we're using. So if our NAS uses Windows and we have a Linux computer, then we might even be able to access the files, but they're not going to behave like native files on Linux file system. For example, they might have wrong permissions or it might be unable to track permissions just because it's a Windows file system and not a Linux file system. And the way in which Windows tracks permissions is incompatible with the way that Linux tracks permissions on files, so we can't interoperate on that front. Network attached storage works well with any app because we have this networked file system interface, so it's the file interface that applications normally use. So this is very convenient, and we can mount these network attached storage file systems anywhere, including containers. So they're very flexible. On the other side, the storage area networks works with any operating systems because we create a block interface and then we can do whatever we want with it. So it's very flexible and we can create any type of file system inside the block device that we created. And we can create any file system inside the block device. One problem is that block devices are not directly usable by applications, including containers, because applications usually use the file interface, so they can't access block devices directly. And it's harder to share data that is stored inside the virtual disks because the operating system has to be involved in mounting the virtual disk, and then the file system has to take data out of the virtual disks.